In this lesson, we will learn how to relate graphs to events. Newspapers, books, and magazines often use graphs to display data. So why do we need graphs? A graph shows complex relationships between variables in a simple visual way. So by using graphs, we can show relationships between variables in a simple visual way. Drawing a graph makes it easier to see trends and changes in data. You can use a line graph to show how data such as speed or distance change over time. The line graph below shows the speed of a commuter train as it makes a morning run. So let's look at the graph. The time is plotted on the x-axis and speed in miles per hour is plotted on the y-axis. And this is the journey of the train, starting from 7:30 up to 8 o'clock. And this is the increase in the speed of the train. This is the speed being constant, and this happens to be the speed coming down, slowing down. What does this mean? It means that the train is at rest. It's not moving. And again, the speed of the train is increasing. Speed is constant over here, and the speed drops, and so on. Let's answer the questions based upon this graph. How long did the train's trip take? The journey started at 7:30 and it ended at 8 o'clock. So how long did the trip take? The trip lasted for 30 minutes, right? Starting from 7:30 to 8 o'clock. Between which two times did the speed increase the most? The speed has increased over here, over here, over here, and over here. So between which two times did the speed increase the most? It increased from this point to this point. So what is the point over here? It is, say, 7:49. So the speed increased from 7:49 to 7:51 and 7:51. So between 7:49 and 7:51, the speed increased the most. So if we just look at the graphs once again, look at this, from 7:49 to 7:51. 7:51, because if you drop a line over here, it's going to be 7:51. So the speed increased from 7:49 to 7:51. When you draw a graph without actual data, without actual numbers, you are making a sketch. If you observe this graph, it is with actual numbers, 7:30, 7:40, 7:50, 8 o'clock. So this is a graph. But when you draw a graph without putting on the actual data, you are actually making a sketch. Let's see how to sketch a graph. Kim measured her pulse rate occasionally during a 45-minute workout. The workout included a 10-minute warm-up period and a 10-minute cool-down period. So in a workout, the warm-up was 10 minutes, and then there was a workout exercise, and then the cooling period, she cooled down for 10 minutes. Sketch and label a graph showing her pulse rate during her workout. So we are required to sketch a graph of a pulse rate during her workout. So let's see how to sketch a graph. And this is the graph now. The time is on the x-axis and the pulse rate or beats per minute her heart rate is on the y-axis. So when she is at rest, her pulse rate is normal. Can her pulse rate be 0? Absolutely no. That means her heart is not beating. But when she is at rest, there is some pulse rate at some point. So then her pulse rate is normal at rest. So we start off from here. Now, during her warm-up period, will her pulse rate increase? Yes, so her pulse rate goes up. And then when she is exercising, after reaching a point, it's constant while she is working out. Steady rate during workout. Then during her cool down period, she has stopped exercising, so obviously her pulse rate will come down. And then it'll come back to normal. So this is the sketch of a graph of Kim's workout with a 10-minute warm-up and a 10-minute cool down. So look at this, a 10-minute warm-up. So she started warming up at 10 up to 20. And then she started cooling down 40 to 50. So how long did she actually work out? She worked out for 20 minutes because from 20 to 40 minutes she was working out. So by looking at this graph, we can understand her exercising routine.